Okay, this one. All right, so in the last three sessions, we have in some parts we're using functions, right? Like the print, the int, the float, range. What other functions did we use? We were using methods, right? Like the string methods, list methods. There's even dictionary methods if you've decided to explore that one. So, um, now we are at the point where we are the ones creating the function, right? Because odds are there will be times that instead of copying and pasting the code of all the time, it would be easier for us to. Sorry. All right, apologies. So I have cough today, so yeah, I'm gonna stop once in a while to cough. Um, where was I? So there will come a time when you're doing projects. There's gonna be parts where it's gonna be better if you make that block of code into a function, right? In order to organize your code more efficiently, right? And if you program that way, right, using functions as kind of blocks for your program as a whole, you're kind of like, um, in a way, you're kind of like preparing your program to be modular. So what they mean by modular, like you can swap things out with a different code base or content of that same function, and it would still work, something like that, right? So what they mean is when you say modular, you can you can think of it like Lego blocks, right? Each function as a Lego block, and you can swap things around as long as the parameters and the outputs remain the same. So the logic inside of it may change, right? You may have created a new code that is more efficient, so to speak, and then you just change the code inside of that function, right? Or have both of the functions present in the code base, but you just declare that you're going to use the newer one. So you're kind of swapping them out, right? So your program is now modular as long as the parameters and the return statements, the return data types remain the same. So essentially, it will still function as long as the logic works inside, right? So let's start first with how to create a function. So if you want to create a function, you start with the def keyword. This is what tells Python that you're going to create a function. After that, hold on, did I hit record? Yes. This is going to tell Python that you are creating a function. Next is you assign a name to it, like my function. It's gonna be blue in Jupyter Notebook, depending on what you're using or the color scheme that you choose. It might be a different color, right? After that, you will have open and close parentheses to indicate that it's a function, and then finally a colon, right? Now, the moment that you press enter, it will automatically give you an indentation, right? And every line after that, so on and so forth, will also give you an annotation to indicate what grouping, right? Remember, the indentations will indicate the nesting and the grouping of your code, all right? Now, let's start with a very simple function, right? Also, as a review for what parameters are, um, what arguments are, and what are return statements, right? So let's start with a simple function. I want a function that will print my name every time I call that function. Okay, that's a very simple function, right? Now all I have to do, now I have my function, right? Now all I have to do to use that function is to call it, right? So like this. Sorry. Okay, so let's try this one out. And as you can see, when I run a block of code, um, it will give us an output of data, right? So it works exactly like any other function that we have. We can even put this one inside of a loop, right? For example, I want this loop to repeat 5 times, so for x in range 5, right? I want this one to repeat 5 times. I'm just gonna call my function 5 times like this one, and then it will have that kind of effect. Uh, so let's make this more interesting, right? Let's go to parameters and arguments, right? Now, let's say our function will accept one parameter or one thing that can adjust the way our output looks like um, using an argument, right? So the argument is the actual value that you are passing to the function when you are calling it. The parameter is the temporary variable that holds the argument, and that is what the function is referring to whenever the function tries to use the said value, because the function doesn't know the actual value, it just knows where to get the value. That's what the parameter is for. It's a temporary variable. It is where argument is temporarily stored while you're using the function. It is not accessible anywhere outside of your function. That is its scope. It only exists inside of that function. Alright, now let's start with a very simple name. You start with the name of a parameter. Let's say it's param. That's the name of my parameter. Okay? Now, if it's just this, right? Let's try if this will work. So run. It will, of course, return an error. It's going to say, my function, missing one required positional argument. So it says required positional argument. So the error occurred at line 6. This is line 6 here. Line numbers, line 6, right. It says argument. So it means we're missing a value here that we need to pass because we're calling the function my function, right? We're using my function. Now, it's positional because it has no default value, right? So one is positional argument, the other one was a um, key value pair parameter, right? So again, argument is in the perspective of using a function, right? Parameter is in the perspective of the function inside of the function. Okay, now we're missing an argument for the parameter called param. All right. Okay, so it doesn't really say what it needs, but since it doesn't really say what it needs, we can just pass anything whatever we want, right? So how about I will pass books here, the string books. Now, if I were to run this code, it will run, but it doesn't make any sense, right? We're passing a argument. This argument now is saved temporarily inside of param, right? So imagine Python going here, line, and it stops at 6. Python says, okay, it's gonna use my function. So it's gonna go back here, look for where the function was defined, while carrying the value books. So it's gonna say, hey, my function, here is the argument for you, right? And then my function is, okay, I'll store this in param, right? Now it's in param, but we're not really doing anything with param, right? So what do? We can try and have another output here. Let's say print, say this is param, right? So we're using the param parameter. We're making it dynamic, this output, because anytime that the param changes, the output also changes, right? So if I were to, oh no, wait, since this is repeated 5 times, let's put some kind of separator on our output. So something like dashes, like this one, so that we can see each repeat of the call my function, right? Sure. All right. So it's gonna say Daniel's books 1, 2, 3, 4, 5. Right. So now it's working. Excuse me. So now we see that it's repeated 5 times. It's using the argument that we are passing, and we're also using the parameter, right? Um, what else can we do, right? So earlier, remember the error that we did not pass anything? So it says missing argument, right? But what if you don't want to pass anything? So what do? So in those cases, you're gonna assume that what if the user, right, doesn't pass anything? That one of the ways that we can do is put a default value for that parameter. So we're gonna put an equal sign here, and I'm gonna say this is the value here is a string as well, and it's gonna say this is no value. All right. So now, if I were to pass nothing, no string here, right? The output should look like Daniel, and then this is no value. So that's my expected output. And as you can see, that is how the output would look like, right? So now this is not a positional argument anymore. No, because this is now a key value pair, because you are referring, you're going to have to refer to, if you want to change the value here, you're going to have to refer to it by name, param, like that one, right? Or, although not strictly speaking, it's not like 100% not a positional argument, more like the standard way to use them, if you have a key value pair, you would almost always indicate it using the key, like this one. You're gonna have to call the actual name of the parameter rather than depending on its position, right? You're gonna reserve the positional arguments for the positional parameters. That's the kind of rule, but it's not really stated. It just makes things more easier per se. If you are going to use parameters with values, then use the actual parameter names. So earlier, when I say param slash books, right, that was wrong. No, wait, when I said my function books, that was wrong. It should have been my function param equals books. This is how you should write it in the correct way. Although the two would produce the same result, right? If you were to say this one, this is what we had earlier, right? Although although the two will result in similar outputs, right? This is a better way of using the function. This is something that's more understandable to your colleagues, to other developers when they see your code. So you're going to have to write code while thinking that what if someone else would read this? Like, can they understand my code, my logic here? If you're using some kind of complex logic, then you're going to have to indicate the reasoning using a comment, right? But don't forget that one. Excuse me. Sorry. Okay. So, did I unmute? Alright. Um, what else can we do? Mm, let's see. Parameters, arguments, return values. Let's try and use return values. So what are return values? Let's see. If we put something like a return statement here, that means after you use the function, it's gonna return something else. Okay, so let's say I'm gonna return the string done. Okay, the string done. Right. So what does this mean, right? So this function, right? Remember, Python will take the argument books, goes to function, the my function, and then they talk, right? So he says, Python says, hey, my function, here is your argument for the parameter called param. It's a string books, and my function says, all right, I'll take it, I'll save it, I'll give it to param, and then after they're done, after executing codes line 2, 3, and 4, right, my function will say, oh, by the way, I'm done. Okay, I want you to return this string called done to whoever um, was using our function, using the function. So Python says, okay, I'll bring this back. So Python carries the string done, goes back to this line where my function was called, right? And then it's going to say, hey, here is the return string, return value from my function. It says, okay, I'll put it here, exactly where I am, right? So this here, after everything's done, will replace this entire thing with that value. Alright? So what does that mean? It means we have a value here after it's done using the function. So that means we can save that value, assign that value into a variable, right? I'm gonna call this one my var, for example. Now, in order for this to work, we have to like see this on the output, right? We can now print this one, and say my var. Yeah, let's see what this looks like. Also, I want the separator to be here now, because since we have another print statement after the function, it's gonna get confusing if we have it here. So we'll remove this one, put it on the for loop, and then run it. So now this is what it looks like. It's gonna print Daniel. This is books, and then done. So why is done being printed out? Because we are returning the string done in this location, right? It is now saved to the variable called myvar, which we can then use in any way that we want, such as printing it. And this is what we see here. And now automatically we have a separator here that will just uh, indicate for us visually that one iteration of the loop is done, and then it goes to proceed on the next one, right? So uh, first loop, second loop, third, fourth, and a fifth loop, right? So range of five, it will repeat 5 times. Okay. All right. So that's the basic concept of a function, right? Um, Technically, you can put anything that you want into a function. Anything and everything that we have discussed before can be put inside of a function. Can you put a function inside of a function? Yes, you can do that one. It's called recursion. Recursion is uh, a solution to solve a problem by calling a function by itself over and over again until you reach a certain point where um, you get the simplest answer possible, and then work your way back slowly. Now, I don't want you guys to focus on recursions at this point, since programming is relatively new to you guys. So I want you guys to focus more on the concepts, the um how do you call this? The concepts, the way of thinking when you're programming, right? Um, Recursions are just like really fancy ways of solving a problem. It's really efficient, it's really fancy, it's very nice to look at, but um, if it really doesn't solve anything, then it's not really that useful, right? So um, it's more like it's reserved for at the very end, when you have optimized everything. You try and see kind of like which ones can we make into a recursion so that this becomes a few percent more efficient, right? You can squeeze out more performance that way. That's why they do that. All right. Now, that's basically it. That's what a function is. So we've discussed parameters. You've already know how to read parameters, right? And their definitions when you go online. Look for their syntax. Okay, so this is how you actually create those functions. Um, so there's no need to go back on that. Mm, let's see, what else am I missing here? If you want more parameters, then you can just separate them using a comma. Again, it's just the same concept. You're using two parameters instead of one. Um, if you want something to be required, right? Remember that one. It should be a positional argument. It should not be um, a key value pair, a named parameter. Um, yeah, so that you don't have to put a default value, and it would force the user to actually input something past an argument when they're using the function. All right. Let's see. I'm trying to think of the things that I missed. If there's anything. Return. Is there a question? Is the scripting case sensitive? Yes. So if you were to say my var, right, that is strictly different from my var, right? So case is very important when you're programming, so you need to be careful with that. Well, on that note, there are certain rules that programmers follow when creating variables in that way. We have a camel case, so that is every word. The first letter is capital. We have, forgot the other names. I'm sure this isn't camel case, but you start the first word with a with all small letters like this one, and then the first word after that, the words after the first word always have a capital first letter. So this is my preferred way of doing it. Others like having underscores. I don't really like having underscores. I kind of want to reserve underscores for a very specific purpose, like important values that are used in my app or in whatever I'm doing. Okay, like if you're into web dev or servers, you're gonna have something called secrets. Yep, they call it secrets. And what is that secret? Well, it can be anything. Like it can be the way to access the server. It's not straight away like a username password. It's more like a verification, right? So you're gonna refer to your secret, right? And how do you know that it's a secret? Well, you refer to it by um, you know, just visually, right? You will see immediately, like if you have a variable called myvar, this one that I'm using, but I have an underscore after that, it would recognize it immediately as I would recognize it as okay, this is something that's related to logins because I put an underscore in this variable. All right, you get my point. So this is something that I do, right? Other developers have their own thing, right? It's up to you guys what you want to use. Whatever is comfortable for you, right? Remember the help, the help, right? We had that one help, and then oh wait, no, the dir, right? If we were to look at the dir and then int, okay, can I see? Yep. So if you've noticed, they're using two underscores before and after the name of the property to indicate that that is a property. All the other things are methods. So that's how they kind of like use this one. Okay. But there are other ways of doing this. There's no rule that you have to follow um, in order to be um, good with this. So you just have to be consistent, right? Like if you want it to be done a certain way, then you just have to follow it. However, when you're working in a company, you're just gonna have to adapt to what they use, right? So they're gonna have their own standards, their own way of naming things. So you're gonna have to adapt to how they do it. That's just how it goes when you work for a company. All right. Okay. What else did I miss? So that was actually a good question. Let's see. What else did I miss? Hmm. We have classes, but I want to reserve that one for something else. So classes are like blueprints. Let's see. So let's say, right? Let's say, remember objects, right? So I explained objects as a complete description of something. So that description involves properties and methods inside of it. Okay? Now, a blueprint, right, or the class is something that's higher than the object. Okay? Now, for the object, I use the example cars, right? Now, um, whenever you're creating cars, you have to follow a certain blueprint, right? All the cars have a frame. All the cars have wheels, depending on how many wheels you have on that car. All the cars have an engine, right? So there's a blueprint to the basic um, structure of a car, of the object that is called car, right? It's the same way how it works in programming. All right, we have an object. That object comes from a class. Okay, now this is where it gets confusing really fast. That's why I don't discuss class like this one. I actually want to reserve that when it gets to the advanced parts, right? Where uh, you're kind of like creating your own blueprints, so to speak. Because in a way, you can create your own objects. It's very easy, right? But creating your own class requires a little bit more understanding, right? More experience yet with using Python or a programming language before you can actually utilize class um, more effectively. Otherwise, I think it's just more confusing if you were to learn classes now, right, at this point in the beginning. So I'll try to omit that one for now, right? But just remember there's something higher than that one, right? And if you want a analogy, it's a blueprint, right? That's the blueprint. So um, if you want it, let's say we have an object, right? We have a car, but the the part where a frame and an engine and then tires, it's just not for a car, right? What if the tires, the number of tires was 10? Then what you have is now a truck, a 10-wheeler truck. So now the object becomes truck, not anymore a car, right? If you have an object, right? And then from the blueprint, okay, you have a frame, but your wheels are just two. Then what you have is a motorcycle, not anymore a car, not a truck, a motorcycle, right? It's still the same. It has a frame, it has number of wheels or tires, it has an engine, right? But the actual look and feel of the object itself is different, right? But they all came from the same blueprint. You understand? That's what I'm trying to say. That's the higher version. All right. So if you were to name that higher version, what would it be? It would be something like vehicle. That would be the class name, vehicle, right? And if you kind of understand that, right? The way that objects work is that um, in real life we do modifications, right? We do modifications. So what do? We know the blueprint, we know the created object. What if I want to say I want to add something more to this, right? Okay, so let's take the um let's take the hmm, let's take the motorcycle for example, right? You're a developer, right? And then you see the product motorcycle. Okay, I know where this comes from. It comes from the class vehicle, and then it created an object, um, an instance of that vehicle class, and we're calling it a motorcycle. Okay, now I want to add something to this. I want this to be even more than a motorcycle, right? So now you want to add like I don't know a rocket to the back of the motorcycle just for discussion purposes, right? So it comes from a class, right, called vehicle, and then we it created an object called a motorcycle, right? Now you want to create something new that is better than a motorcycle. So what do you want to do? You want to um, take whatever it has created, this one, and you want to add something. So we call that extending the class. We're creating some kind of modification to it, right? So now your extension would have a new property or method that is attached to it. So um, now it would have something like maybe booster, right? You can have different kinds of boosters. You can have a rocket booster, a NOS system, if you guys know what a NOS is. Um, So it's nitrous oxide. Um, I think if I'm correct. Yeah, I think I'm gonna just confirm. I might be telling you guys the wrong thing. NOS nitro. Nope, 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 nope. For racing, nitrous oxide. Yes, that's correct. All right. So yeah. Now your new class here, of motorcycle. Maybe you can name it something else other than motorcycle. Um, but this one has another one that another probably just added to the blueprint, which is the booster, right? So that's the way that they structured um, objects in programming, and this is how it works for other programming languages as well, so that anyone, right, can extend anything that already exists. Okay, so this makes it easier for what? This makes it easier for us to expand technology because something already exists as the foundation. You understand? So, Python is the foundation, right? You want to extend something, you created something new, you added more functions, here comes pandas. If you want to extend pandas, right? You added some things, right? Here comes what? Something that's good for machine learning. TensorFlow, for example, right? So you can build something new on top of something that's already existing, that's already good by itself, right? And then using that as the foundation, you create something more. And this is how other um, other libraries are created as well. They are created on top of already existing technologies, already existing libraries. And it all comes back to this very simple concept of classes and extending, and then modifying the object that it creates more and more. Okay? So you can trace that one really if you have time. But for now, I'll just leave that one for you guys as something of a um, optional assignment because again, like I was said, it can get very confusing at this point. All right, let's go to map, filter, and reduce. So we need to go down for this. All right, let's go to the syntax. What does the map do? All right. If you have to master any of the three, map, filter, reduce, I suggest you master map. Okay? Filter and reduce comes from map. The reason why filter and reduce exist is because they are used very commonly, that the developers decided to, hey, if instead of you guys always using the map to create a something that filters out other objects or reduces things into one, we just created two functions for you that does the same thing. It saves time, something like that. So that's what the developers of Python did. Okay, if you want to master anything, master the map method. If you master this, a lot of options out there will look very very similar to this one, right? So map function. This is not a method. Map function Python. Map. It's also called map, I think, in JavaScript, if I remember. So yeah, I forgot in C++ if it's called map. Let's see. Okay, map function definition. Okay, the map function executes a specified function for each item in an iterable. This item is sent to the function as a parameter. Now it looks very confusing, right? But technically it's just this one. It takes a function, applies a function to each item on the iterables. That's what it means. Okay, so let's go to some examples, right? Here are some examples, but it's a very simple example. Let's do one ourselves. Here. Okay. Oh yeah, by the way, for this, you need to really understand how return works in order for the map to be very useful. Also, the map function is something that we call a higher order function, right? It's still a function. It's the same as every other function, but the way that it makes it higher order is because it takes in functions as an argument, right? Kind of like an inception thing. It's taking functions as an argument. Now, let's do something like this. Def, let's see. How about power? All right. Um, I'm gonna take a parameter called x. Again, yeah, by the way, don't name things like x, y, and z. Try to be descriptive with your parameters, with your variables, right? So that it makes it easier for the user, the reader, your coworkers to understand your code, right? Especially your lead, because they're gonna keep asking you what was this? Why do you have something like X? It's very confusing. So that's not good practice, and it will often lead you to like um, more questions from your lead, right? So better to be descriptive, okay? And if you want to be descriptive, that usually like takes focused like um, intention at that moment. Like you're really thinking of something. Right? For now, I'm just focusing more on the application, right? I can't think of anything, so I just name it X for now. But remember to name it using uh, good descriptions. Now, def power X. What will this do? This will return the value and raise it to the power of X. So, so, so. No, wait. To the power of X. No. Power of 2. I think this is much simpler. Alright, power 2. Um, take any number and then return the square of that number. Something like that. Yeah, that's very simple. Um, Alright, so assuming that X now is the number, what do I do? I want to square that one. So I can either do something like X times X. That is correct. Or you can use a function that can give you power, like if it's more than 2, but that's not the point. The point here is that um, we are trying to demonstrate the map. Okay, so um, this is how I will modify the value of the iterable at that point. So I'm going to get one value, double it, and then I want to return it. So I want to return this value. So that means I can just do like this directly, right? I don't have to. Um, I mean, I can if I want to put it into a variable, but um, that's just inefficient, right? This is already a value itself. I have no need of this value in this function anywhere else other than to return it. So I'll just return the value itself immediately. Next is we have to have an iterable. So what is an example of an iterable? We have what? We have strings, we have list, tuples, dictionaries, sets. So we'll go to the simplest one, right, that we know. We'll go for list. So this is my list. I'll create my own list. Alright. Now, alright, what are the values of my list? Let's start with 2, 4, 6, 8, 10. Something that's really visible when we multiply by the power of 2. right? So the expected answer would be 4, 16, uh, 36, 64, and then 100. That is my expected output, right? Um, okay, now how do we do that one? So if I were to say, mm, right, uh, my result, okay, I'm gonna, what, call map on this, and then I'm gonna pass power of 2 here, power 2, yes, and then I'm gonna pass my list here as the iterable, right? Now, I should have the result. The map will, what does it say again here? The map will, the item is sent to the function as a parameter. No, 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 no. Required, required. So it doesn't really say what the map will output, right? But yeah, let's just run this one. As you will see, let's try printing what will the map give back. My result. Sorry. Map object. What's this? Did I forget something? Let me go back to the. Mm, did I forget something? Where is it? Why is it showing my object? This is a reference to. This is a reference to memory location. Why is it showing me a reference? Map object. This is an object, alright? I want to see what's inside the object. Why is it giving me the location? Alright. Let's use the IR on this one. Let's see. Alright, so we know that this is something. Where do we get the value? Size of. Here you go. So the class, right? Remember that what I was discussing earlier. It actually saves in the dir what class it is, where it came from. So if you want to look for it, it's there. Let's see. What do we use here to set strings out of string? Mm-hmm. All right. All right. So, um, I just basically forced it to show me what is inside of it. That's why I'm using the list here so that I can see what's inside of the um, map, right? So what's inside of my map is this. So now you can see that for each value, each item, right, is actually double in each um, similar index location, right? So 4, 16, 36, 64, and 100, right? So this is what the map will do. This is what will happen when you use a map, right? A function is applied to each item that you have and will return um, a new value, right? You can use this one to get the value, right? And then use it however you want, okay? So, let's see. So the definition here is kind of missing, right? Let's try and see how it's being described in built-in functions. This is max map, okay? Function iterable forward slash iterables strict false. Return an iterator that applies a function to every item of iterable, yielding the results. If additional iterables arguments are passed, function must take that many arguments and is applied to the items from all iterables in parallel. Hmm. This is where the max. Hmm. Returns an iterator. So that explains earlier why if we use my result directly, we would only see the location of it in memory, yielding the results. Let's see. How should I apply this to other iterables? Usually when I use this, it's always a list. It's the most like handiest one to use for a map. Um, iterables. Yeah, because when you're working with data, especially in data science, you're gonna be involved with either rows of data, right, or columns of data. But more commonly, it would be columns of data. You would use the map method on a column of data, and then you would get the return of that value, whatever function you want to use, um, to get a result. And when you're referring to a column of data, they would all have the same data type, obviously. If you're referring to a row, that would be very, very difficult because each one would have different data types. That means you have to take that into account, into your code, into your function, and then detect it first, what type it is, before actually doing anything else. So this is more commonly applied to columns of data where it's um, of one data type. And when you do that, it will almost always be a list. So that's why I always see this one as a list. Um, yeah, so that it'll actually have an example here that we can explore on, right? Even this one only has one example. By the way, you can click on this if you want. So it will give you something like a description. So as you can see, it still gives you a map object, and it's also using the list to convert it into a list object for readability. But this is actually like what it says here, an iterator, right? So this is something more advanced, um, something that you keep on calling in order for it to work. But we don't actually see that one happening here. It's something happening internally, right? Now you might be asking, so it's not really that, it's not really that useful, sir. I mean, what can we do with that, right? Now let's go to the second one, which is not that one, which is a filter. Now this is the good one. Now you can start to see how powerful the map method is. Filter Python, right? Like I said, these three are the most common. You use the map when you want a custom function. You use a filter and reduce for, you know, if you want to filter or reduce something. So, filter, of course, you're gonna remove the ones that you don't like. Returns an item where the items are filtered through a function to test if the item is accepted or not. Alright? Now, it's still the same. Filter, function, iterable is the same way as the map, right? But the way that it produces output is different. It has an example here. It will basically have something like this inside of it. The important part here is the true or false. There should only be one result. It would either be true, it would either be false. What would happen if it's true? It would save that result. If it's false, then it would um, it would remove that one, right? It will not include that in the new output, right? So it's using age here. It's looking for all the values that are greater than 18. So in other words, the adults, right? So let's do something similar, but um, let's see. How about a certain grade, right? So definition grade checker, right? You have a grade here, and then you want to check the grade. So just like what the example did, if x is greater than or equal to 75, for example, we will return true. You can have multiple return statements. However, once one is encountered, it will end that function at that point. Okay? It will end the function at that point, and then it will go directly to the next line of code after the function, right? So, um, else, if it's not greater than 75, uh, it will return false, of course. What is necessary here for the filter to work is it's looking for the boolean value true or false to determine whether to keep something or to throw it out, right? So, um, we have passers here, right? We're gonna use the function filter. Uh, what do you do here? Filter, and then you pass in grade, and then you pass in your list. We have a list here. My students, these are their grades. So 67, 89, 95, 45, 80, 69, 78. Alright, I think that's enough. Pass this one here as my iterable students. And then print it out. Print passers filter object. Right. So um, we already know that objects in the past, oh no, in the map are iterators. So if it's an iterator, aside from using the list, we can go ahead and use them in loops, right? Like what we did with the example, what was shown in the example earlier. So yeah, that's something you can do because the range function, if you remember, is also an iterator. It works by calling it. So what does this mean actually? That means the value, right? The actual value is not really prepared in advance. It's more like in order to save memory and processing power, it only gets the new value once you requested it. Hence, that's why it works for a loop. So for x in passers like this one, and that's also why it works for a list. Why? Because when you're using the list function, you're basically asking for the whole thing. So you just keep on using the function, the map or the filter function, until everything is done. That's why it will just give you a simple list. In this case, right, you want to see which are the passers, right? So for print x, we want to see which grades pass um, this condition. So we can see that 89 is a pass, 95 is a pass, and then 78 is a pass. All right. So this one is false, so disregard. This one is true, is pass. That's why we have it here. Pass, output, false, false, pass. So this is how filter works. All right. Again, with the passers here, we're using the variable passer because we need to save this one into a variable in order for this to work. Now, whenever we're using the in here, right? We're looking for the first what? We're looking for the first item in this iterable, and since this is an iterator, it will just give us the first one that it creates. So the moment that we requested this one, it's gonna take 67, check if it's true or not. Then, since it is false, that is what it will give us, right? In memory, it has no value yet of the results of the following items. It, however, saves where it last stopped, right? So since this is a loop, right, it's not going to print anything. Python goes back to line 11. So it's going to say for x in passers. Now, it's going to say, hey, give me the next item, right? So this is where I stopped last time. Okay, I'll go to the next one. Okay, I'm going to return true for this. Okay, here you go, true. Filter says, okay, this is true. This is a pass. You can go through. Python gets the new value, puts it in X here, and then prints it out. That's by what we see. That's what we see here. Okay? Now, like I said earlier, the filter function actually just comes from the map method, right? If we were to convert that one, say something like this. So we have a map, right? We have a map, and then the function that it will use, my function, for example, and then the iterable my students, right? Now, you were to apply my function to each one. Now, your function should be something like this. Def, right? Your function should be filter. True or false. Hold on. Mm, okay, I'm still thinking. So there's two level to this. The first function will check. No, wait, that's just wrong. We can't check true or false twice because that just doesn't make sense. If we were to convert the map into a filter, it would. What do we need? We need a way to check the true and false. So what we need to do would be if we were to just use this one as is, true false, true false. Mm, all right, this is actually kind of tricky. Let's see. If I start with being all right, I think this will take us a bit of time. Unless you guys have some kind of idea, that would be good. Right now, I'm having trouble converting the map into a filter, but I do know that the filter just comes from the map. Um, I just haven't tried it before programming it. Let's see. All right, maybe I can think of something else later. But let's see. Hmm. If I were to check this one first, why would I want to check that one first? Oh. So if we were to just copy this code, right? Um, let's start in a new uh, sheet, new cell. Uh-huh. So I'm taking this as kind of a challenge for myself. Def, my function. Let's just use this one again. Right, and then if we were to copy the code that we did earlier, right? Uh-huh. Alright, now I have X here, the map, my function. We have the list of students here. Alright, my students. Okay, So if I were to return true or false, what would happen? My map would look like a list of true and false. That's not what I want. What I want is the actual value. So instead of actually returning true and false, I would return X. Otherwise, I would. What will I do? If I won't return X, what will I do? Huh. I would. I can't return nothing. I mean, I can, but it would serve as an extra step. I can just. I can just skip this whole thing. And it will only give me whenever it's true. That would. Like. Yes. I think so. If I were to. Here. What? Expected. Oh, yeah. Sorry. Expected one. Yeah. None. None. Yeah, okay. So there's like another result here, another if. That's not part of the map. So if like y is equal to the value of none. How about I'll just put an else here and then exclusively put a return of none. The string none. So the reason why I am exclusively writing none here is so that um, I know that it will be a string. So if y is none, then uh, wait. I'm just gonna detect if it's not a none. So if y is not equal to none, then that is what I will do. Print y expected. Alright, there you go. But I'm doing some extra steps here. So essentially, we can still use the map for this, but as you can see, we have more logics behind it to do. But you can just skip this whole thing and just use filter, okay? So this second check here, right? This second check is more like the true and false part. Because in the filter, we need to return either true or false. So it's gonna use that result inside of it to see which one it should return or not, right? If it's true, then it will return the value. If not, then it will not return the value. But all of that is incorporated inside of the filter function. So they just transform this entire thing into like a simple function. But I know it's something more complex inside of it. It's not something this simple. There should be more checks inside of it. And yeah, that's good. We were able to solve it. Last but not least, the reduce. What does the reduce do? So the reduce is it will give you only one result in the end. So this is good if you want to like get the sum or something like that. So let's see. That's not what I'm looking for. Python functions, reduce function, Python. Okay, let's just use this one. Alright, so this is a different resource. Function, iterable, and the initializer. Okay. So I haven't discussed this one yet, lambda. Essentially, this is just a function, but it is a nameless function. So why do they do this one? Is because they don't want the effort and the time it takes to actually create their own functions with good naming, good something like that. All right. If you want to create a function that's only used at that specific part of the code and then not anywhere else, like you're not going to be using it anywhere else, then you can just use a lambda function for that one. So it is a nameless function. Um, yeah, that's basically it. It's just a nameless function. So you can insert it anywhere that you want. But it's kind of limited. So for now, just reserve yourself to creating functions. Um, if you see something like that, lambda, just assume that it's a function. All right. What will happen? So we have a list here. Let's see. It takes two arguments and returns a single value. All right. In here, it reduces them. The function is very simple. It has two parameters, x and y, because it will take two arguments. So 2 and 4, it starts with 2 and 4. It places 2 at x, 4 at y, and then it will add them both. This is the block code, right? The block inside of the function. It will add them and then return them back. So what would happen here? It's 2 plus 4, that's 6. 6 will be um, the new value, but that value is just saved internally for now. So we have 6, right? We call that one the accumulator. It's not really stated here, but it should be called the accumulator. But anyway, so we have 6, right? Now, it's gonna use 6 as the new x. 6 as the new x, and then y as the next value, which is 6. So now if you add them together, that's 12, right? Now, 12 will be the new x, and then 8 will be the new y. If you add them, that's 20. That's why we have 20 here as our output. So that's basically what reduce is. Okay, so using the function that you give it, it will get two items at a time, right? Do the calculation, get the result, and then save that one as the new first variable. And the second variable will be reserved for the next item in the iterable until you only end up with 1. Alright, so this is very good when you're trying to reduce the result into 1, right? Like right now we're just adding them up, but you can actually use this one for something like you're looking for the largest value. That's a good idea, right? Let's try that one. So you're looking for the largest value. Um, let's start with this one, right? You have my students. You want to look for the largest grade that is on this list. That is actually a very common task. You're looking for the largest thing inside of a list. Now, there are other functions for this other than the reduce, but what I'm trying to say is we can also use reduce for this, and it's more flexible in a way because you can customize the function that you are using. Um, so let's go ahead and see. You're looking for the largest value, right? All right. Def my function uh, x and y. Okay. If x is greater than y, Okay. If x is greater than or equal to y, it should return x, else return y. All right. So that's it. I think this will work. What we have to do now is save this to a variable comparison. Uh, I just call this comp. Comp is equals to reduce, right? And then my function, and then uh, what do I have here? My students. Why is reduce not turning into green? It should turn into green. What's this? Reduce is not defined. Why? It's called reduce. Oh, alright. Okay, it's not included. Um, okay. We need to copy that one. So it exists in a different part. Is it? Func tools, import, reduce. Idle. It says idle. Oh yeah, I forgot to print. Comp. Sorry. What is happening with my fingers? There you go. So, as you can see, it checks two items at a time, and then it will always return the one with the bigger value. So, as you can see, it effectively combs through the entire iterable and gives us the highest value, which is 95. Okay. Um, did I forget something here? Yeah. So it's not readily available in Python. You have to get it from somewhere called func tools, all right? And then you're gonna import that a function, all right? So the same as when you're importing like a player in basketball, right? It comes from somewhere else, and then you put it into play. This is how it works in programming as well. It comes from somewhere else. From where? It comes from this place, this um, script, supposed to be, yeah. It comes from functools. So inside of functools, one of the functions in there is reduce. And we don't want to import the whole functools. We want to import only reduce. That's why we can use it here. That's why I was concerned earlier, because it didn't turn into a different color. That's one indication where something might went wrong, and it did. And I did not notice this one earlier, but it came from somewhere else. Alright, aside from that, that should be everything. Okay. Of course, there are more functions that are higher order functions other than map, filter, and reduce. But these three things have served me a lot, really, um, in different cases. Alright. And they are very, very useful, actually. So, again, if you want to master one thing, try mastering the map. Look for exercises that involves you using the map, different case situations, right? Okay. Any questions before we proceed? All right. That's good. No questions. That means you guys have understood everything and internalized everything. So that means it's time for an exercise, right? I have three exercises, so I'm gonna choose three of you. Right. So just like before, I created easy, medium, and hard exercise. So let's start with an easy one. this should be for 10 minutes, right? So the first one is, oh yeah, by the way, at this point, this is all the topics that we discussed, right? So the exercises that follow will require you to use everything that you have learned so far, including the things that we have discussed last week and today. Okay? Right. So you got this, guys. Okay, the first how do I make this bigger? This one. The first exercise, the secret code validator, right? So these are the concepts that you can use. Um, Create a script that validates a security key. So here are some of the things that it needs. It needs the user to input a key. Check if the string AX exists anywhere in the key using if in. So there's a suggestion already. Check if the last three characters using slice or numbers. Okay. Check if the total length is exactly 8 characters. So you can use len on this one. So if all the conditions are met, print access granted. Otherwise, use dir string in your console to find a method that can convert the key to all uppercases before printing access denied for key. Alright, so the reason why it will convert, we need to convert everything to uppercase is so that if anyone is viewing your screen, they don't actually know if you're typing it in capital or I think that's the reason. So this is just one of the exercises that I found online. So I'm taking this one the same time as you guys. So if no answer is given, then we'll try to solve this one together. But I'm sure someone can answer here. All right. So yeah, using these parameters, create a program. Um, yeah, good luck. So I think 10 minutes is enough for this. It's 2:50 on my clock. I should check back on you guys at around 3 or 3:01. Uh, yeah, that's all. If you have any questions, just call my attention. I'm right here. Okay? All right, timer starts now. All right, it's 3:01. Does anyone want to volunteer their solution? Anyone? All right, so I'm gonna choose someone. Okay. Hazel, I did not see you last week, so I want to hear from you today. Do you have a solution?
Um, okay. And,
You can
I'm
go
not
ahead and share your
sure.
screen, by the way.
Hold on. Window.
All right.
I'm just playing around and check some. So I'm not sure if this is accurate.
All right. Let's see.
So what
Okay.
I
Explain your
did,
code.
can you see? Okay.
Yeah, we can see your code.
So I did key, um, what do you call that? So our task is to create a script that validates a security key. So the first requirements is ask the user to input a key. So I have here key equals to input and then enter security. Uh, and then check if a string AX exists anywhere in the key using if minus I. And so I just tried
All
and
right. It's okay.
almost
Yeah.
X coded for the AX and then check. We have also checked if the last three characters using the slicing semicolons are number. So I just put it on the Y. So I key and then the last three digits. So and then the fourth one is check if the total length is exactly 8 characters using the len. So I use the z equals to len, the key equals to the 8 characters.
All right.
So we have the condition that if it is met, uh, a print access is denied. And then otherwise, we have to print access denied for. So I'm trying, I'm trying to test it. So far, I have a result like I have the word here. So I just key in a random AX and a numbers here, and I was
Yeah, because right now you have 9 characters. So try
yeah.
inputting. Yeah, try it again, but only up to 6.
Okay.
Okay. Access
Yeah.
granted. All right. Can you try? Uh, so it's looking for AX, right? Try a different letter, like any letter. Try. No, no, no. I mean, when you run the program, when you enter the security key, try a different letter combination.
Can you repeat that again? I did not hear it clearly.
Run the program again, and then I want you
Okay.
to input a different
Instead of
key. Yeah, instead of
okay.
one with an AX. Yeah.
Okay. Like for example, and and then a random number.
Two, four. Wait. 2, 4, 6. I think you have more than one. All right, try that one. Why is that access
Oh,
granted? So it's not looking for AX, and I think it's because the logic is wrong.
Oh,
Your logic is if X and Y and Z, but in the part of X is not really looking for AX. So I think what you need
oh,
to put there is to say X in key. Try to no, not there, in the condition, in the if condition. Yeah. X
if
in
X,
X in key, space key, right? And then that whole thing from X up until key, put a open and close parentheses. Put
like this
put
one? No.
no. The opening parenthesis is before the X, closing after the key.
Okay.
Yeah. So just like in mathematics, right? You kind of group things so that no, X in key and then closing parentheses.
Sorry.
No, that was correct. That was correct. So okay, before the X, put a opening parenthesis. Right?
Close
Yeah, and then
parenthesis. And
close.
then,
No. The close is after the key. There.
okay,
Yeah. So
okay,
yeah,
so,
kind of like you're grouping things in mathematics, right? Okay. Try that one.
okay.
So it should not grant you an access. And one, two, three, four, five, six. One more number. Access
So,
denied. Okay. Try to have the first two characters as letters. Try T and Y.
T,
T and Y, and then any kind of number. Any six numbers. Okay, there. Access denied. Alright, try it again. But AX is alright, so try 1 4 AX, 1 4 AX, and then 8, right?
same
So
number.
four more numbers. Four more numbers.
Okay.
So that should return as granted. All right. Next is I want you to um input five numbers first,
Okay.
five numbers first, and then AX, and then one number. So that should be denied.
1, 4, 6, 8.
All right. Okay.
Oh, perfect.
Okay. So yeah, good work in
Thank you.
reaching about 90% of the solution in under 10 minutes. So that's actually very good. How about for everyone else here on the room? Did they get um did they understood the solution that Hazel showed? Or do you have any kind of question for her or for me? All right. I think yeah, okay. I think they don't have any questions. All right, so hopefully that's clear. Yeah, thank you for that, Hazel. All right, let's go now to the next exercise. Okay, now this is the hex color filter, right? You have a list of decimal brightness values. So this is from 0 to 255, but you have some numbers here. Okay, the logic here is you create a function called isBright. It will return true if it's greater than 100. So anything greater than 100, any color that's greater than 100 is considered bright. I want you to use the filter and only give the numbers that are greater than 19, greater than 100 back. Okay, and then you need to create another function that converts that decimal into a hex string, right? And then what is that? Use map to convert your filtered list of bright. Yeah, okay, yeah. So the final output should look something like this one, similar to this list. So yeah, it's basically you're just passing around the different data types and then some conversions in between. But you're gonna be using the new things that we have learned so far. So filter, map, conversions and creating of functions. So yeah, that's why I put this one in the medium difficulty level, right? So since this is medium, actually I think 10 minutes is also enough for this. So yeah, same as before, 10 minutes for this one, and yeah, we'll see later on. Timer starts now. All right. So it's 3:24. Hopefully that's enough time. Anyone want to volunteer? Aside from Hazel. All right. Nobody wants to. All right. I'll pick. Um, let's go with Joker. All right. Yeah, Joker, are you here? You're free to share your screen.
Um, it's a bit complicated. I'll
Again.
sige, I'll try.
Oh, okay. All right. All right.
Can you see it?
Yep, I can see it. Okay, can you explain to
So
us your code?
these are the values.
Mm-hmm.
Then the function. Anything more than 100 is bright. Then another function converting the number into hex.
Mm-hmm.
And I define the bright values, filter them. If it's bright, and then create another hex values where I map and list anything with bright values and convert them to hex. and then print the hex values.
Right. So the logic seems correct. OFF. Alright. Okay. Alright, so the logic seems to check out. Um, since we already have a variety of values, I don't think we need to have other values. But, this is the solution that we have here is at its simplest form, right? We're not incorporating yet anything advanced like um, error checking or data type checking. The same with Hazel's work earlier. We did not incorporate any of those things yet, but at least um, in a logical standpoint, it works perfectly well. All right, good job, Joger. Thank you for showing and sharing your answers. So, for the others that are listening, do you have any questions or did you arrive with a similar solution as well? All right, so I'm gonna assume everything's fine with it. Okay, now we're gonna go to the last exercise. All right, so I reserve this one as the hard part. Um, this primarily involves dictionaries, tuples, reduce, default arguments, and methods. Okay, the task is to manage a ship's inventory using a dictionary where the keys are item names and values are tuples containing the first value would be the quantity, the second one would be the price per unit. So the example here, we have the inventory, right? That's the whole dictionary. The first one is O2 tanks or oxygen tanks. There is about 5 tanks and 100 per tank, whatever the denomination may be, since this is a galactic inventory, right? Fuel cells, right? So it's up to you to think up of unique things in your inventory. If you can't think of anything, then just name it whatever you want, X, Y, Z, uh, so on and so forth. Requirement, write a function, and that function's name would be add item. So it needs the name, the quantity, and the price. The price is default to 10. That adds or updates the dictionary. Note the default argument for the price. Okay, so I take note it either adds or updates. If it exists, it updates. If it's not, then it should add it as a new key value pair in the dictionary. Right? When you use inventory.items, it will um, give you uh, everything that is in your dictionary in tuple format. The big boss here, big boss has used functions that we use to calculate the total value of the entire inventory. All right, take note total value. That means you take the quantity multiplied by the amount. That's the value for that inventory, and then you total for all the other items you have in your inventory. Calculation logic will be multiply quantity by price and then sum all of them up into one final number. Alright, so it might sound difficult and complex, but if you break it down into smaller steps, it's actually quite easy. So, yeah, okay. Let's go ahead and have 10 minutes for this one as well, right? Um, yeah, I'm confident you guys can do this. So, timer starts now. Okay, that should be enough time. So, yeah. Hazel is done, Joker's done, Edmund, Justin. Anyone, which one of you wants to volunteer? Alright, so no one wants to volunteer. Okay, since there's two of you, let's flip a coin. If it's heads, it's Edmund, tails is Justin. Right, so flip a coin. Coint. Flipping heads, so it's Edmund. Alright, Edmund, do you have a solution? If you have, you can share your screen. Hello, Edmund. Are you here? Edmund, hello? Maybe your mic is on mute. Alright, so it seems that Edmund is not currently available. Justin, do you have an answer?
Meron naman po.
Alright, you're free to share your screen.
Ayan, nakikita ko, ayan. Bale ito yung inventory, tapos ito yung function, ta's ito yung iche-check if may existing, how do I say this, yung same yung nasa inventory niya. Ta's itong print na manifest, yeah, for item, ito yung item, 'tong zero tanks, ta's quantity, price, and quantity and price, ta's inventory items, ipi-print niya bawat isa. So ito print the tanks, ta's quantity 5, ta's units dito 100, ta's isa din eto din. Ta's dito sa yung mag-a-add na sa total value, so total value equals sum. So quantity times price siya dito, 5 times 100, 500. Tapos, yeah, for QTY, ta's price in inventory din. So 10 times 500, ay 10 times 50 is 500, ta's isa-sum siya. Kaya nakuha yung 1,000. Naka-store siya sa total value variable. So, ayan, naging 1,000 siya.
Mm, okay, let's see. Um, alright, so I like that you're using values, even though it wasn't indicated on the instruction, so that's good. Um, I also like that you formatted your output. Let's see. Okay, can you try adding a new item? Let's say, I don't know. What's what's a futuristic item? A vibranium, right? And then it's 15 units. No, no, no. Using the function. Using the function. All right. So somewhere in your program, use the add item function. you will add a new item, and that item will be vibranium. Its quantity is at 15, and then the value is at um, let's see, the value is at 100. Oh no, wait, 150. I think 150 is good. All right. So yeah, that's it.
Sorry, dito po ba?
Oh no, you're gonna use the function. You're using the function. You're not gonna edit anything
Like hindi siya
in the definition.
hard code?
Yeah, you're gonna have to put it in some other parts of your code. You're gonna um, add a new item, right? So at this point, you're just manually indicating in your code that you want to add a new item. But in real life, it should be like you're gonna be asking the user for this. But in this case, you can just use
Hmm,
the function directly. Okay, so try put it after the for loop. No, no, wait, before the for loop. Yeah. I want you to use the function right there. Add item, right? And then, no, no, no. You don't have to. You're using the function now. You're not creating the function again. You use the function.
I'm sorry, clueless ako. How do I use the function?
Oh, you just call the function directly. So add item, add underscore item, just like in the other function, like print, int. You just call the name of the function directly, open and close parentheses, and then you provide the parameters that it needs. Alright, so name is vibranium, right? And then the quantity is 15. No, no, it should be separated by commas. Because in the definition, that's how you created it. You said name, and then comma, and then quantity, right? So that's how you should also put it when you're using the function, just like any other function that we are using. And then you say price, okay? Price,
Question.
yes, Joker.
Hi. Can you just edit the inventory part, the database, the dictionary itself?
Yes, you can, but I wanted to see if the add item function will work.
Okay.
Yeah. All right. So let's proceed. Add item price equals 150. 150. All right. Okay. Can you run the program again? Okay. So I successfully added 15 units at 150, and the total is still there. All right. So it works. Um, okay. The reason why I wanted the function to work is that in the future, right? So let's put ourselves into an actual company. We wanted this one to be in production. That means we want this one to be used by everyone. So when different like users wanted to add an item, they can just maybe click a button, and that button is connected to a function. The function would be add item, right? So at that point, we don't actually need to edit manually the database, right? Because that's the last thing that you want to do in like in anything really. You don't want to manually edit the database. That's just a big no-no. That's the last resort of the last resort. uh, so if you want to edit something in the database, you have to go through the functions that are set for that function, for that process. So for editing, adding, deleting, it has to go through those functions in order to have security, right? So that's one of the reasons why they do that. You never edit the database manually. That's just a big no-no. So, yeah, seeing that it works, that's good. You can make this more dynamic and maybe ask the user for if they want an input, right? You can put everything into a while loop if you want, so that the program kind of never ends, and it just keeps you giving the total manifest, and it keeps on giving you the total inventory value every time. So yeah, there's a lot of ways you can improve this one, right? But um, I'm getting off topic, but I hope you understand the reason why we're doing this. All right. So, what else? On the sum function, um,
Sorry.
Justin, no, it's okay. On the sum function, Justin was using, if you guys remember, that was called a list comprehension. So that's kind of like a shortcut when you're using the for loop. And each result of that is directly added to the sum, right? So the sum is kind of like how reduce works, but it just added it just adds them all up, right? So actually that was, I think that was the original instruction. Use reduce. Yeah. But instead of using reduce, Justin used sum. That's okay. At least the result is, what we wanted. So that's good. All right, thank you for that, Justin. Okay, so we're done with the exercises. Next is we should go to web scraping. All right. So before we actually discuss this one, I'm gonna give you guys a. Oh no, wait. I don't think we have time for that. We're gonna discuss this one today, and then also next week. Oh no, wait. Next week would be the continuation of this and pandas, and then I'm gonna give you guys a project that you're gonna do, and that project is the for everything that you have gone so far, applied into a single project, for web scraping, right? You're gonna pick your own topics, your own projects, and then uh, you know use that one as a part of your showcase to your future employers that you know what you're doing, and then you actually did uh, research that you were actually interested in, and then you wanted to know using the data that you gathered yourself and see what it would look like, right? So something like that. It actually has more impact to the interviewer than actually, doing 1,000 lead questions, or uh, knowing how to, like, what are different difficult questions nowadays. Uh Reverse binary tree. I don't know. But yeah, if you're into this field, if you want to proceed into this field, the key to improving fast is to create projects, right? Projects that interest you, so that you don't lose momentum when you're making them, right? Try to commit like an hour, 2 hours a day if you can, to coding, writing code, researching what to use, um, looking for the library that you might need, so on and so forth, right? The entire thing, right? And all the way to the presentation, right? So supposedly we're gonna have to, like, one session you guys are gonna present, but I seem to have made too many exercises. Maybe I should have stuck to two per topic, but I wanted everyone to, like, have their own participation, so that's why. But that's okay. I'll try to finish everything, web scraping and pandas, today and next session. And for the project, we're just gonna have to communicate maybe via email or something, in order for me to confirm your submissions, right? If I'm good with it, right? But I highly encourage everyone to uh, have their submissions as well, right? Okay, so we haven't had any breaks yet. Let's have a quick break for everyone. It's already 4. It's a long overdue break. So let's have a quick 15 to 20-minute break, and then when we come back, we'll start with web scraping. Um, yeah, so the difficulty will spike a bit because we're gonna learn something else. We're gonna learn something called HTML. We're gonna learn a little bit of browser tech. We're gonna learn about CSS as well as a little bit of JavaScript and what goes underneath the browser, right? We're gonna learn more libraries and a lot of things actually. We're gonna learn a lot of things. So like the level of difficulty will spike starting from here and towards the next few sessions. All right. So I hope you're excited for this one. Have a good break, get some coffee, get some snacks, and then be ready when we come back. All right. See you in 20. All right. So I hope everyone had a good break. So I went over like 10 minutes. Okay. Is everyone here? All right. Thumbs up. Okay. So I think Edmund went out first. He didn't leave a note, but that's okay. All right. Let's continue with our lesson. Okay, where is it? Mm, um, this one so that I can show the window. Okay, okay, okay. All right. Mm, okay. All right. So, how to scrape the web? You see. Um, hold on. Okay, first we need to like understand a few things first before we can actually start scraping the web. All right. First is we need to understand how a web page works, what makes a web page, right? How the browsers interpret that web page, like how do they understand it as the web page, right? How is it loaded into your screen? How does it all work together, right? Um, okay. So the first thing that we need to do is we need to understand HTML, right? So HTML, it's not really a programming language. More like it's the backbone of a web page, right? It's the structure where everything else is attached, right? I want you to keep that um, analogy in your mind, right? Like, think of the HTML as the skeleton, right? You're not programming the skeleton per se. More like you're indicating like how many arms, how many legs there are. Okay, um, that needs to be there on the web page, right? And then what goes where is it attached to, those kinds of stuff. The stylization, of course, comes with it. Yeah, so we need to understand that one. What else? The different technologies related to the web, like fetching, we need to understand it as well. Uh, the browser, how we're gonna use the browser. We're not limited to Google Chrome. You can actually compare this one. What you've learned here, you can compare this one with the other browsers. Um, Other browsers have their own advantages compared to Chrome. Um, they have like some of them have similar tabs and properties, but some have more details. Like Firefox, I think Firefox has more um, things to show than Chrome in um, their tools when you're viewing the web page. All right, which we'll get into later on. Okay, so let's proceed. This is a very basic overview of how to scrape the web. Sorry. Okay, so you start in the browser like this one. Okay, and you type in an address at the top. So when you're typing an address at the top, like Facebook, for example, you are basically using this command called fetch in JavaScript, right? And that command will, of course, from the word itself, fetch the web page from the server. Okay. Now the server is just another computer somewhere in the world. Okay. Um, Now it says here using requests, right? So this is only for Python. How we emulate this one, right? We have to use the request library. That's what we're trying to say. If you're using a different language, it might be a different library. So yeah, um, that's basically it. Now, what the server will give you after you make that request using fetch, they will give you first, one of those things is the HTML file. HTML is short for hypertext markup language. Okay, so hypertext, it's not just text, a lot of things come with it, right? It is the structure again, and from that structure it can start requesting other things that it needs, right? Like images, other libraries, links, videos, you name it. Okay. Now, from that HTML, right? What do we need to do in order to scrape the web? Why do we even need to scrape the web? Let's say, for example, there's data in a certain page that you're looking at, right? Let's say, uh, I don't know. Let's go for Yahoo. Yahoo Finance to be specific. All right. Let's say you have a page like this one, right? And there's data in this page that you want to retrieve. Let's say it's the uh, most active and then the top losers, right? All right, so and the top gainer. So this three tables here. This actually updates every few seconds, I think, or I think every minute. So this is dynamic data. This is a dynamic web page because it has a part that automatically updates without needing to reload the entire page, right? So there's two, static page and then a dynamic page. A dynamic page gets new data without reloading. A static page, right, gets new data, but you have to reload the page, right? Um, or most of the times it doesn't really get new data. It's just that page itself, a static page, nothing else. It doesn't request anything. It's just a simple page, right? So, what does this mean? Okay, let's say we want to get these data, right? In order to get these data that appears in our screen, we have to like um, know where to find this one, right? Now, again, I said HTML is the backbone of the web page. Everything that you need can be found in the HTML. Everything that you see here can be found in one way or another on the HTML page. Okay, so especially text like this one, you can see these things in the HTML. So, uh, that's why we need to learn how to read HTML because we want to know where to find these things, get the data, and then use them for our projects or research. Right? So that's just one example. Okay. Um, right. So that's the extraction part. Right? Now, we want to extract that one. Right? Um, we want to extract the HTML, right? Not the data yet. We want to extract the HTML from the page. So let's say, all right, here's the data that I need. I want to get the HTML of this page. So that's what the extract here is there for. Okay. Now what will you do with that page? You will need to get the HTML tree, right? Specifically using the library called Beautiful Soup. All right. Now, um, what is the HTML tree? So basically, what we want to do is we want Python to understand how to read the HTML. Why? Because we're going to be using Python to look for the information automatically and repeatedly if we want. Okay? Now, again, I said this data updates every few minutes. So we want Python to look at this part of the HTML and then save the data every minute. Okay? Now, in order for Python to navigate the HTML, right? It needs to understand first how to read HTML. All right. Now, when you say you want to understand, you want a programming language to understand something, right? The common word that we use for that is called parse, right? Parse means to understand. So you want to parse the HTML file so that Python or whatever language you're using can understand it. Once you can understand it, what can you do? You can go anywhere you want, right? So what do you mean by that? Imagine you are in a um what do you call that one? Imagine you are in a warehouse, right? Now, at the beginning, you're gonna get lost. But as you know where the different sections are, this is the section for the biodegradable. This is the section for the curtains. This is the section for anything else, right? Once you know where to go to, right? Like the different offices, emergency exits, everything. You understand where to go, right? Um, it makes it easier for you to find the data that you need, right? And that's exactly what we're trying to do. We're trying to look for this specific data, okay, using the commands or functions that are available for us, right, in Python, and using the library, of course. Beautiful soup, right? Now you see the HTML tree looks like this, right? We'll explain more in detail why it actually looks like a tree, okay? Alright, now these are the HTML basics. Um, Question, is the basics enough? Yes, you don't actually need to learn the whole HTML. Of course, learning more doesn't really hurt, right? It gives you an advantage, but learning the basics is enough to get the data that you want, okay? This is the basic structure of an HTML. It will always have the HTML at the top and at the bottom. All right, it always comes in pairs. This is the opening tag and then the closing tag. The closing tag is always the one with a forward slash at the beginning. Okay, this indicates different group. Now you might notice that there is some indentation here. This is not the same with Python. These indentations are for readability purposes, not grouping purposes. The grouping here is indicated by the opening and the ending tag. So this is the open, this is the end. Anything inside of it belongs to this group. So we have a head here, open, close. Anything inside of this belongs to the head. So this one belongs to head, right? It doesn't really matter if they are in one line or in multiple lines like this one. What the browser reads, or what we read actually, is where it starts and where it ends. Okay? Anything in between is considered text that you see here. Okay? Text, plain text. Right? No need to complicate things. That's text. All right? Now, in the opening tag, you will see different attributes, right? Now, these attributes look very familiar to us as developers, right? It looks like what? A key value pair that we see in functions, and um, instead of a colon, it's using an equal, but it looks like a key value pair for dictionaries, right? You have the name, value, name, value. The separation here is just a space. There's no need to put a comma. Sorry. So, yeah, each attribute has a different purpose. Just like parameters, you can create your own attribute if you're developing a website. So, no need to get confused if there's a lot of these things that you see, right? The important things that you need to consider is when you're looking for information, you need to look for the things that make it unique, right? And most often, 90% of the time, the thing that makes it unique is the ID, the class attribute, and where it's located. Like, if you absolutely are sure that there is only one UL tag in the HTML, in the entire HTML file, you are sure to get that information every time, right? So the key here is to look for something that's unique, right? Where your information is located. Then you can start going to the next steps, right? Okay. What you need to remember is that attributes, right? The values are always in a string format. And it will always use open and close double quotes, not like in Python where you can use single quotes, right? That is always how it goes, whether it be numbers or text, right? It will always be in this format. Okay, so that's the basics that we have to go on. Okay, here are the other tags that you might find helpful. These are actually found on the previous one. So we have H1. This is a header, right? Biggest to smallest, H1 to H6. Anchor tag A is for links. So if you see something that's a link, like this one, for example, um, you know that it should be inside an anchor tag. So it should be inside an A, right? Um, Web developers have this thing called feedback, right? They want the user to feel that they have selected something. So when you if you put your mouse over here, it changes color. It shows you a kind of like a pop-up box to give feedback to the user that they are currently hovering or selecting that part of the HTML. So just that's just a quick note of like what are the different signs if you're looking at the link or not. Okay. What else? It doesn't really show here, but all right. So from other sites, when you hover over a link, okay, yeah, here you can see on the lower left. There's if you see the yellow one, you can see on the lower left the link. That's the link that is displayed. That's how you know that um, what you're hovering at is a link, and that is a clue that there should be a anchor tag inside of it, right? P is for paragraph. This is just for content purposes only. Div and span, right? Used to create division or span around some items. But basically, when I use these things, it's when I don't know what tag to use. These are the things that I use: div or span. Okay. If I don't know what to use, I'm gonna use div or span. Um, that's basically it. So what does that mean? It's not really that unique. Okay, so don't depend on these tags too much. Next are the lists. So whenever you see something that's ordered, like this one, or um, like this, that something that looks like a list, right, with numbers in them. Let's look for something else. This can be considered a list because it's like one thing or another. Uh, okay, this is or yeah, this one. Actually, I think this one could be a table. Yeah, I think this one looks like a table. Yeah, let's go back here. So when you have a list, right? We have two types: ordered and unordered. Ordered list is one with numbers or Roman characters, something that you can read, right? Unordered is something that you can't read. So bullet points, dashes, or if you want, sometimes there are custom made unordered lists, right? It will appear unique. Like if you want a Pokemon to appear instead of a bullet point, you can. But yeah, and each one of those inside of them has a list item, right? Kind of like how this one works. See, UL, LI, 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 right? Okay. Last one is table. We have table header, table row. We have TD, that's table data. We also have um, we'll have table header. So the other parts aren't actually that useful, right? Usually when you have the TH or the TR, you get the data already. So that's why it's not shown here, the other things. But there are other parts of the table, right? Okay. Anyway, you can see the tag that the data that you want is attached on. So you can just use that, right? Next is this one. Alright, so let's install Beautiful Soup. The command that you see here, this is for when you are installing using the command line. But what we're using is the navigator. Alright, so I'm gonna switch screens. I'm gonna tell you guys what to install since it's already 5. What to install in advance so that next week we'll proceed very quickly, right? So we need to install Beautiful Soup. Let me switch screen. Alright, this is my Anaconda Navigator. Okay, so yeah, I think you guys can see it. I can see it on my screen. Okay, now a library is just a small file with dedicated functions for a certain purpose, right? The purpose of the Beautiful Soup is to parse or to understand the HTML file. Okay? Another word that you might hear is framework. Now, that's entirely different from a library. Okay? Framework is um, the entire thing. You have to change the way that you think when you're trying to program in that framework compared to when you're programming in Python and you're just using a library. Okay, so an analogy to this one is let's see, um, framework. Okay, let's say for vehicles, right? Let's say you're used to driving cars. All right. Now that um, if you're driving different types of cars, like like a sports car or a hatchback, uh, uh, like maybe a panel or a pickup truck, right? They're just kind of like different variations of a car, right? So we can treat them as having different libraries to make it better, something like that. But if I tell you to drive um, a boom truck or maybe a heavy machineries like an excavator. Now that's entirely different, right? The controls are different. How you move is different, right? So you have to what? You have to adapt to that machine rather than the other way around because with different cars like the one that we had earlier, all you had to do was it's like you're in the same seat, right? Just a few things added. But frameworks, right, or the heavy machineries, you have to think different. You have to drive or work with it differently. Okay. Now the way that the reason why I said it is because when you're researching something, in the future, avoid having to learn about frameworks for now. Okay, try to be comfortable first with Python, libraries, and so on and so forth. Okay, okay. Now we're gonna install our very first library. Okay, this is using Anaconda Navigator. The one that I showed you earlier in the PowerPoint is using um, the command line interface. All right. Um, to be safe, whatever you're using now, right, try to follow the instructions that they have. So let's say if you're using Visual Studio Code, this is how to install our library. Just follow those instructions. But in this course, we're using Anaconda Navigator. This is how you use it. And honestly, this is very easy and more user friendly. So this is good for beginners. Now, all you have to do is go to environment, right? Make sure you click the drop down and go to all. Okay. Now, when you click all, it shows you everything that um, the navigator is connected to. Right. Now, the navigator is currently connected to uh, the default, right? It's in the Anaconda itself. You want to add something else, like a third party collection of libraries, so to speak. So, where do we find those libraries? Okay, so this is one of those things. What you need to do first is click on channels, right? Now, when I click on channels, it should show you a box. I'm not sure if you can see the box, but it should show you a box, right? It should tell you um, that there is manage channels. Manage channels you want Navigator to include, right? And you should only see one. I think that's defaults, right? What I want you guys to do is to add another one. So on the upper right, there should be a button called add. When you click on add, I want you to type the following. Okay, so let me copy and paste this one. All right, I want you guys to add this channel. All right, now this channel is perfectly safe. It stores third-party libraries that are well maintained and used by a lot of developers. Okay, um, are there other channels out there? Yes, but this is one of the safe ones. It's big and yeah, it's one to use. Okay,
Can we
after
see it again?
yes,
Can we see it again?
okay. You mean the other box?
No, I just clicked the add button and it's asking for enter the channel.
Okay.
And what channel is that again?
It's in the chat. I sent it on the chat. Do you see it in the chat box? So that's what you need to type after clicking on add. Do you
And
see it?
then
All right. So
yeah,
after
I copied the link
okay,
and
so
then
after copying it, paste it on the text box, and then you press enter. After pressing enter, you click on update channels. Okay, so I think I should share my whole screen for this so that you can see the box. Okay, wait. Entire screen. Okay, share. All right. So hopefully you guys can see my entire screen. Where is it? This one. All right. So here is the other box. I can't really move it around. This is where you put the Conda Forge after clicking add, and then click on update channels. Okay, you need to press the enter key in order for this to work. After that, you're gonna see some green bar. It's gonna update your list. Okay, but after done updating, it should update your entire list here. Okay. Um, and when you click on channels again, you should be able to see Conda Forge like this one, right? Like it has a delete or trash can icon on it. That means it has successfully integrated the channel into your navigator. Okay? Now, after that's done, it might take a while depending on your connection. But yeah, assuming that you're done, what you're gonna do is you're gonna look for the package that you want. So, Beautiful Soup is shorthanded here. It's called BS4. Alright, so you type it here, BS4, and you should see this. Alright, now as you can see, mine already has a check. That means it's already downloaded in my system. If this is blue, that means there is a update available. It's up to you if you want to update. It's generally recommended to update. What does it look like if you don't have it? So if you don't have the library yet, it will look like an empty box like this one. Now, if you click on the box, you will see a downward arrow like this one. When you see the downward arrow, that means you are selecting that library for download. What you need to do next is to click on the apply at the bottom. Okay, remember to do this for the BS4 library. Okay, now when you click on apply, it will start downloading and installing the things for that library. Okay, now it just depends now on your connection and the service, if it's not if it's busy or not. All right, so sometimes it could take 20 to 30 minutes from my experience with my other students. Some have finished it within 5 minutes, so it really depends. Okay. Um, so yeah, after that's done, when you look at the file again here, you should have the check mark available on BS4. Okay, so that's how you know that you have installed it successfully. Okay, so hopefully none of you guys will encounter an error. Some of my students did before, so we had to like use up some time to fix it, but hopefully it doesn't really happen to you guys. So yeah, that's it. That will be your assignment. Installing BS4. The other one is this one, Pygo. Alright, so BS4 and Pygo. I want you guys to install this in advance. It's perfectly safe. It's used by a lot of developers, and we're gonna use it next session. All right. Any questions before we end our session?
The Paiga, it's we don't need to look for the link address, right? Just look
Yeah,
for
you
it in
just need to
the.
type it on the search bar. Pygo. It's
Okay.
included in Conda Forge. They have it there. All right. Any other question? Clarifications? Okay, I think there's none. Okay, again, next week there's no class due to the Holy Week, the service of the Holy Week. Our next class will be on, next and last class will be on, uh, classes will start back at Monday, April 6th. So April 11 is our session 5. So yeah, enjoy the long weekend. Um, Spend time with your families, and yeah, thanks for listening and participating in our lessons and exercises. Thank you guys. Goodbye.
Thank you.
So bye.
Thank you. Bye.
Welcome.